Hey everybody, and welcome to another Jamovi tutorial. In this tutorial, we are going to explore yet another additional module that you can add to your base Jamovi statistics game. In this one, we are going to be talking about adding the randomizer module. There it is, the randomizer module. Again, to add modules, you click on modules itself, and you go to Jamovi library, and you can see that I already have it. Once I scroll to it. Randomizer, there we go, by Michael Bomford. Randomized balance, single factor, or full factor experience using completely randomized complete block, or Latin squares. So I want to show you how to do this and then play around with the information that you get, right? Because you can use column header in Jamovi's spreadsheet with levels of that factor listed below. It's a great little thing. So let's jump into some data. Before I do, I want to mention that I am using the current build version 1.6.16 to, as far as I'm aware, this is what is the most updated version as of recording. So let's grab some data and jump into it. Okay, so I've opened the RTFM data from the data library. It stands for Read the Forkin Manual. And so here we have 8 students, 1, 2, 3, 4, 5, 6, 7, 8, their grade on some test, and whether or not they attended class and read the forking manual. So this data has already been completed, but what if we just had our attend and reading and we don't have a grade yet? And we want to make sure that we end up with a randomized set of data when assigning conditions. So attending, 1 is yes, 0 is no. Reading is 1 is yes and 0 is no. So we have 4 conditions. So let's jump into randomizer here. So randomizer, not a very noticeable icon there, but you click on that and we have 3 options. And we'll go through each of these 3 options. Hopefully attend and reading are useful enough to just do this, although I might need to add in addition of 3 or 4 more additional variables to work here for the Latin square to be actually useful. But let's do a completely randomized design on this one. And so, so this module does not care about the data you already have written in the data set. You can just put in a random set of variables with nothing in the row data, at all. You can just have your column variable names. But for the sake of ease, I wanted to go ahead and use something that was fairly simple, but also clear, right? Because we have 2 variables and they have 2 levels each. So you can see that we have, just by default, we have our factorial design set up. 2 factors with 2 levels each. It's a 2 by 2. Now we have these additional pieces here. We have treatments, replicates, plots, and seed. And now seed is an interesting thing because you can save this seed and plop it in here so you don't have to do this randomization again. Not to say that the randomization isn't easy to do once you put it in here. Like, this is not a cumbersome set of functions and features and options and button presses. But you can take the seed number from here and reseed a completely new replication randomized design strategy. So let's say if you wanted to run 100 people on sample 1 and then do the same randomization on sample 2 with a completely new set of 100 different people. So that's one way you can do that. Now we get the 4 treatments here because our levels. So we have a 2 by 2 factorial design, and we have the amount of times we want to replicate that randomized pattern. So how many times do we want each of these treatments to show itself again in our list? And of course, you would come to the amount of replicates based on how many people you want in each group. Because we are only doing 4 replicates, we're going to get 16 plots. 4 treatments by 4 replicates gives us the amount of plots. By default, so 4 is in here by default. Design properties, that's what this is. And degrees of freedom tells you where you're going to be. So 1 degree of freedom for my 1 level, for my factor 1 IV1, factor 2, another degree of freedom there, degree of freedom for my interaction term, and my error is going to have 12 because I have 15 total people that are going to be in this randomization. Again, the 8 people that exist in this data set don't actually matter. We can just name variables without anything in the rows. We can just make columns of variables and just save that as something completely different, or use that as our entering in later. I mean, it's just whatever you want. Now, you can also get the plot map here. So the plot map will give you a color-coded design. This is amazing. Color-coded design, and I do recommend a legend, and you can change how many columns you get in that. And so the idea here is this was randomly generated. The 0, 1, 0, 1, 1, 0, and you can see the treatments are, and because we have attending above reading, that this is the not attending, not reading, not attending, reading, attending but not reading, and doing both. Okay, so that's what each of these colors mean, and this was randomly generated group of 16, so a 2 by 8 row here, right? So 2 by 8, and we can also get the plot list. So the map will regenerate, and we can get this plot list, and we can get all 16 plots, all 16 people, we'll call them, depending on whether or not you're working with people or things. You know, these plots represent which treatment condition you are going to be doing at that particular time. And again, this randomization matches this randomization. And again, this is seed 5327. So if you wanted to redo seed 5327, then it will auto-populate. But let's say I need to run 100 people in this 2 by 2. So I want to get 100 plots of 4. So I'm actually going to do 25 here because 25 times 4 is 100 plots, right? So we know we have 4 treatments. So we're going to multiply that by 4 to get our total number of people. And you can see that this is plotted out like crazy. And again, it has a different seed value. And we get our degrees of freedom. And here we have the color coded, but we could put this in like 4 columns. If we did that, let's see what happens with the 4 columns. There you go. A little bit more readable when we do it that way. And you can take this to the bank. Again, same colors, randomized ordering for things. And you can see that some of this stuff does end up doubling up or tripling up or quadrupling or quintupling up, whatever, because that's random. But you have the good news here is you have 25, so equal 25 randomized groups. So this would have been useful for me because I used to have to do this by hand. So I'd have a list of people who were signing up for time slots and they would be coming, and I'd have to flip a coin for which condition they would be in, or I'd have to use a random number generator. This module in Jamovi does that for you. It's pretty amazing. So let's before we go into another one, let's add a few additional things. So read the manual. So let's say question. So they either asked a question or they didn't. I don't know why I capitalized it when nothing else is. So let's say they did that, and my levels are going to be going to be 1 and 0. So let's add those. Yeah, there we go. It doesn't really matter as long as they're put in here. And then I'm going to add another variable. Okay, what else do people need to do for classes? They need to go to tutor. Let's say they did tutoring. All right, and so we'll do 1 for yes, and again 0 for no, and that's all we need to do here. And so we have, if we were to do this as a full factorial design, we'd have a 2 by 2 by 2 by 2 because we have 4 variables and each with 2 levels each. It's a little shaky there, I'm going to say. So let's go back into Randomizer and let's go to randomize. But let's do Latin square first, and then we'll go into block design. So let's go into Latin square and let's see what it does. So we're going to select all 4 of these and put them over here. Okay, and generally what you see here is not much different. Okay, so plot them. It doesn't seem to be loading. Hello. Alrighty, so so setting up Latin square design, it appears that you cannot have 4 variables in here because watch what happens. It just completely dies. So if I take one out, let's take tutor out. It doesn't like this one, but so apparently you can do up to 3 factors for this particular thing. So let's manage this, but we can do square format or we can do separate blocks. So let's see what separate blocks looks like. Yeah, so this would be sort of a block randomization. I would prefer the square format for the Latin square. Now, Latin squares, each row and each column represents a different set of. There's no appearance of a single different treatment. So 0, 1, 1. Let's take this one that appears in more. It appears more than once in the same row or column. So we have 0, 1, 1 here. It's 0, 1, 1 there. So that's not in this column. In this row, it's not in this column. In this row, it's not in that column. So you can see it bounces around. So the values, the treatment conditions themselves, the combinations of the treatment conditions do not replicate in more than one row or column. So that's how you would do a Latin square. And you can see that by doing that, by replicating 8 times for 8 treatments. So I assume that it can't do 16 and 16 for some reason. And so you end up with a Latin square of 64. And again, you are the amount of 0, 0, 0 in here does happen 8 different times, but only once per row and column. So that's how you save. That's how you save time and energy with these groups here, is you make this Latin square. And this Latin square makes it super easy to get this down. And again, you can copy down the seed and redo this for another set of data. And I guess it's just a limitation here for the Latin square. Instead of having a 2 by 2 by 2, which is 2 to the 4, which how many treatments is that? There are 16 treatments and 16 replicates. And so 16 times 16 is what? 128? Yeah, 128. So you need 128 squares in here, which would not be great. It'd be 16 by 16. I guess just a limitation of the program. All right, well, that's fair. You can do that on your own, though. All right, let's do one more thing with the completely block randomized design here. And let's go ahead and see. We'll try to put all 4 of these in here now. Let's see if it can do it. It should be able to do this because for the plot map, it's going to be just in the columnar form. You can block by rows. You can block by columns. You can see, so this is blocking by rows, or blocking by columns. If I go back to blocking by rows, this is what it will look like. And so here we have rows, sort of just one or the other, and then you can have separate blocks. Block 1, these are all of the things, no repeats. Block 2, these are all of the randoms, no repeats. Block 3, these are all of the randomized stuff, no repeats. Block 4, etc. Right? And this is how many replications you are going to be doing for each one. So a randomized complete block design is useful for something like I want to take multiple measurements of the same person. So how many times do you want to measure them? That's the number that goes in here. That's how many times you want to measure them. So how many times do I want to measure them? 4 times. That's what goes here. And looking it out at separate blocks is the way that I teach it. And so I'm probably going to adopt this set of randomizer in my teaching, and that'll be it. This is great. This is a great little module for Jamovi here. If you have any suggestions or ideas, tell me how you use it. Leave your comments, suggestions, and feedback down below. If you like this content, please consider liking the video and subscribing to my channel for more Jamovi tutorials, among other kinds of stats-based tutorials and other psych-related content. Thanks for watching.